Bone markings can be the site for muscle attachment, ligament and tendon attachment, and also places where blood vessels and nerves can travel through, areas for those for blood vessels and nerves. So there are three types of markings. If it's a projection, it means it's like an outward bulge. And if it's a depression, then it's a hollowed out groove, like concave. And then if it's an opening, it's a hole. So some examples of projections would be a tuberosity. A tuberosity is a large rounded projection, like for example here, the ischial tuberosity, which is actually the place where if you're sitting down, it's your sitting bones. It's the bone that you put your weight on when you sit. A crest, like the iliac crest in your pelvic bone, that is where your hips kind of jut out near your waist, where you have that hip bone that pokes out. And then a trochanter is a very large process. Here are two trochanters in the femur. I think it's called the greater trochanter and the lesser trochanter, but the femur definitely has two trochanters. And the only ones you have are on the femur. Then you can have a line like the epiphyseal line. A tubercle is a small projection, and an epicondyle is a raised area above a condyle. So it says here the medial epicondyle. So this is the condyle, and then this would be the medial epicondyle. And a spine is just a sharp process. There is in the skull bone. Let me show you if I can find a picture real quick. No, it's probably in chapter 7. You're going to have to learn about the mastoid process of the skull, and there is a spine that kind of sticks out near the mastoid process that we'll learn about. But basically, you don't have to know very many of these. Just know that these names, tuberosity, trochanter, tubercle, spine, process, any of these are going to be attachment sites for muscles and ligaments and tendons. And then if it is a depression, you can have, or an opening, you can have a fissure, which is like a little narrow slit-like opening, or you can have a foramen, which is an open hole, okay? Probably the most well-known foramen is the foramen magnum, which is the hole, you can't see it, it's right, it would be right there. It's the hole that allows for the spinal cord to travel up through from the vertebra. So it's the hole in the skull where basically the brain stem and the spinal cord, travel through. So that is called the foramen magnum because it's a large hole. A sinus is a cavity filled with air. We've got some like the frontal sinus and the maxillary sinus, the sphenoidal sinus, the ethmoidal sinus. These are our paranasal sinuses. A meatus is like a little canal. A fossa is a depression in a bone. So these are just going to be areas mainly for blood vessels and nerves. Now, for cell types of bone tissue, you have osteogenic cells. Those are going to be bone stem cells. That means they're capable of dividing and producing new bone cells. Osteoblasts are going to be bone cells which produce bone matrix. So what happens is you have osteoblasts that secrete matrix all around their outside until they're completely surrounded by bone matrix, and then they will become osteocytes. Then you have bone lining cells, and you have osteoclast. Osteoclasts are opposite of osteoblast. Instead of secreting bone matrix, they will break down bone matrix, because bone is constantly being built and broken down, rebuilt and broken down. It's constantly being remodeled. Osteogenic cells can also be called osteoprogenitor cells. That means they're actively dividing, actively undergoing mitosis, and you can find those in the periosteum and the endosteum, the outer and inner lining of bone. And what they do when they divide is they form osteoblast, and then the osteoblasts secrete bone matrix, and they become osteocytes. Okay, so bone cells begin as osteoprogenitor cells, and those are the stem cells which can undergo mitosis, and they divide and form osteoblast, which secrete bone matrix. And then the osteoblasts become osteocytes, and those are going to be bone cells that are surrounded by bone matrix, and they no longer divide. They reside in lacunae, kind of like chondrocytes. Cartilage cells reside in their own little space called a lacunae, a little cavity. And they don't divide anymore, but they are living cells. And then osteoclasts are cells that break down bone. So between the activity of osteoblast and osteoclast, osteoblasts are constantly building bone tissue, making new bone tissue, and osteoclasts are constantly breaking it down. The bone lining cells have their flat cells on the surface of bone that help maintain the bone matrix along with the osteocytes. On the external bone surface, they're called periosteal cells, and on the internal surface, they're called endosteal cells. That's pretty easy to remember because the outer lining is the periosteum and the inner lining is the endosteum. So those cells are called periosteal cells and endosteal cells. They're just named for the lining where they're found. Osteoclasts are derived from a different line of stem cells. They're derived from the same stem cells that become macrophages, which are the big white blood cells. So they are not derived from the osteogenic cells. They're not derived from bone cells. They're derived from basically blood cells. They are giant cells with many nuclei, so we call them multinucleate. And they function in bone resorption. That word resorption means breakdown. Bone breakdown. So these are the two bone cells that come from bone cell stem cells, osteoblast and osteocyte. And then the osteoclast actually comes from white blood cells, from a white blood cell stem cell. For the microscopic anatomy of compact bone, so in other words, what this tissue would look like under the microscope, compact bone is also called lamellar bone because lamella means layers. If you were to cut it in like a cross section or a transverse section, you would see layers of bone tissue, kind of like layers of an onion. You would see these concentric circular layers called lamellae, which is just means layers of bone. So the compact bone consists of units of bone called osteons. And then running through the bone tissue are canals and little canals called canaliculi. And then the layers of bone are called interstitial lamellae and circumferential lamellae. All right, so an osteon is the structural unit of compact bone. Also see it referred to as the Haversian system. But osteon is much easier to say. So an osteon is like a cylinder, kind of like a straw, but it's not, not completely hollow on the inside. It does have a hole that runs through it for blood vessels, but it runs parallel to the long axis of bone. So it's like you have all of these, just kind of picture if you had 4 or 5 drinking straws in your hand and you were holding them. That's kind of how osteons are arranged, like that. Okay, so an osteon cylinder consists of several rings of bone matrix called lamellae. Those are the layers of bone tissue. And within the bone matrix, you have collagen fibers. Okay, so a single osteon kind of looks like this. It's kind of like a little straw and a bigger straw and a bigger straw, inside a little straw, inside of a middle-sized straw, inside of a bigger straw. You can think of it like that. But anyway, the inside part, there is a canal that runs through the osteon that is where the blood vessels and the nerves would be. It's called the central canal. So your central or Haversian canal runs through the center of the osteon, runs through the core or the center of the osteon, and it contains blood vessels and nerve fibers. And then you have canals called perforating or Volkmann's canals. Those run perpendicular. So if we go back, they would run like, I don't know if I can do this well or not, but they would run like in this direction. They would run perpendicular, whereas the central canal runs parallel to the osteon. The perforating canals would run perpendicular. They would kind of come in from the side like that. And they're also for blood vessels. And then you have lacunae, which are the small cavities that in which the osteocytes reside. These are the mature bone cells once the osteoblasts have secreted bone matrix around themselves. And then connecting to larger canals, you have canaliculi that run through the bone tissue that connect the lacunae to other canals. All right, and then in addition to the lamellae that forms the osteon, you also have interstitial lamellae, which is bone tissue that fills in the gaps. Because if you can imagine, if you had a bunch of cylinders, there would be spaces between them. If you were holding a bunch of drinking straws in your hand, you'd have gaps. So the interstitial lamellae fills in the gaps, and the circumferential lamellae goes around the outside of everything. So this is what it looks like. You have osteons. This is an osteon. This is an osteon. So I'm looking at 1, 2, 3, 4 osteons here at the top. And those osteons are composed of lamellae. And then we have lamellae in between the osteons. This would be interstitial lamellae. And then we have lamellae around the outside of all the osteons, and it's called circumferential lamellae. And you can also see the central canal of the osteons. That's called the central canal or Haversian canal. And then you can see the canals that run perpendicular. They're called perforating canals. Okay, with spongy bone is organized into little pieces of bone called trabeculae. And this is kind of what it looks like enlarged, just spongy bone. It looks spongy. The composition of bone, as far as the chemical composition of bone, the bone matrix itself, has osteogenic cells, osteoblasts, osteocytes, all the different bone cells. I won't highlight all of them because basically it's all the bone cells. And then osteoid, which makes up 1/3 of organic bone matrix, and it consists of ground substance and collagen fibers. So the osteoid is what we call the bone matrix, and it consists of ground substance and collagen fibers. And that is going to give flexibility to the bone, whereas the inorganic components are kind of like cement, and they consist of chemicals called hydroxyapatites, which are mineral salts. So about 2/3 of the bone mass is the hydroxyapatite, which is mainly calcium phosphate. So you have the osteoid, which is 1/3 of the bone matrix, which is mostly ground substance and collagen. And then you have the hydroxyapatite, which is the calcium phosphate part, makes up about 2/3 of the bone matrix. And that's going to give the hardness or strength to the bone, whereas the collagen gives the flexibility.